Hi everyone, welcome back. Let's continue our discussion from the last video. And if you haven't watched that, I definitely encourage you to watch at least the last couple of videos. In the last one, we went through the process of getting your system ready for Mask RCNN, how to download it and get it working for TensorFlow 2.2 on Python 3.7. And the one before that, I provided a quick overview of what Mask RCNN is and also how the evolution of Mask RCNN actually happened all the way from CNN to RCNN and so on. So in this video, I am going to focus on actually using what we have done in the last video. So we have an environment in Python that's ready with Mask RCNN installed. And now let's go ahead and download a dataset with XML annotated data and just go ahead and understand the code and do a quick training. And of course, take the trained model and perform object segmentation on a new image. In the next video, I am going to walk you through this process completely from scratch. In this video, we are going to use existing annotations that someone shared on Kaggle. So stay tuned for the next one where we just download some images from Google by a quick Google search and annotate them ourselves, generate a annotation file, load that into our training, Mask RCNN training, train a model, and then segment it. So do subscribe to this channel if you want to be notified whenever that video gets uploaded. So first of all, let's go ahead and get the task done for this specific tutorial. And again, before proceeding, you can download any dataset. Whatever I'm showing you right now is going to work with any dataset as long as the annotations are in XML file format. And where can you find that? I literally did a quick Google search on Kaggle and I found this dataset. That's not too large. It's only 80 megabytes, right? 30 megabytes, not even 80. It's got a handful of images with corresponding annotations. We'll look at them in a minute, but just want to make sure you know exactly the data set and where to get it. I'll leave the link as part of the description down below. And here it's a data set that has 3 different classes: apple, banana, and orange. And when it comes to coding, I am going to literally copy everything that we have in our Kangaroo test file that comes with our Mask RCNN installation and modify that to multi-class problem. Unfortunately, the Kangaroo one is only a single class, only Kangaroo and background, but here we're going to change that to multi-class. So that's the information. What else do you need to know? So as part of acknowledgement, this person, whoever was kind enough to share this, mentioned that the XML files were created with label image. So if you're wondering how to create these type of labels, go ahead and use label image. Although I'm going to show something different tomorrow. I'm going to show you how to use a .json, like something in the Cocoa format or the VGG style format. But today, let's stick with XML. Okay, with this information, let me fire up my IDE. I am going to use the Spider IDE from Anaconda. I've already downloaded the dataset and a couple, actually, let's go back to the dataset, a quick note about it, because people share data in many different forms. And I am trying to use the code as much as possible, the code from the Kangaroo dataset as much as possible, so I don't have to change a lot from my data handling point of view. So in this case, the way the data is structured, if you look at this, train.zip, let's go ahead and open the train. So they have an image and corresponding XML file, another image corresponding XML file. And they label these images as apple 1, 2, 3, and then you'll see banana 1, 2, 3, 4, and then orange 1, 2, 3, 4, and so on. So I downloaded all of that. And in fact, where do I... Let's go through that. It's very important. So in my data sets, I believe I downloaded that right here. You have apple 1, 2, 3, 4, 5, 6. So obviously I separated the images from XML files, so from annotations. And for each image, there is an annotation with exactly the same file name. Okay, and if you go back to the Kangaroo example, so right there that we saw, that comes with your Mask RCNN installation. So keep these files. And if you look at this Kangaroo training file, which we will in a minute, but if you look at the data set, they have images as 1, 2, 3, 4, 5, 6, like 001, 002, and the annotations as pretty much the same thing, right? 001, 002, and so on. I really want to get this data into the same format. I wanted to, if I go back one more, fruits, data sets, images and annotations. I wanted to get these in the same format. Why? Because when you load the data, when I go back to Kangaroo, okay, they're loading the entire data, and then they're just saying use the first 150 images for training and the remaining for testing, for not for training, basically. If you do that with this data set, if you try to use the same code with this data set, the first 150 images are probably all apples. Then you don't have like any bananas or oranges and any of these included. So we need to randomize this order, right? I mean, I don't want only apples. Or another option I have is go here and change the way the code is written, so I don't have to do that. So I can use the original file names right here. So this is a choice that you have. Either change this code. In my case, I chose an easy path because I know I can write a few lines of code to literally rename these files and randomize them. That's exactly what I have done. If you guys are interested, I'll share this with you. This is again the basics, the Python basics, but if you really think this helps you, I can definitely share that. In fact, I will share this along with the other files that I'm going to share on my GitHub account. So here I'm just taking my images and annotations, and basically I'm randomizing them. You see the shuffle right there, and changing the file names to 0, 1, 2, 3, 4. That's what I did. And if I come back here, rename to numbers, and under images, you see I have 1, 2, 3, 4. They're all randomized. As you can see, you have a banana there, orange, apple, 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 orange, and so on. I mean, this one has multiple. So anyway, so this is what I've done from a pre-processing point of view. If you find another data set that's already ready to be trained, that's fine. But if you're using this specific data set, I'm just showing you exactly the steps that I have taken. So I did, obviously you have to do exactly the same operation to annotations, otherwise your annotations do not correspond to your images. So I did exactly the same. And how do you do the same operation if you're randomizing? That's where you have to set a random key right there. So the random is not so random. It's predictable random. Okay, so that's exactly what I have done. And then I looked at my Kangaroo training file that came with our Mask RCNN. You can go to any Mask RCNN repo, and this is the most commonly used example. In fact, if you look at any other blogs explaining Mask RCNN, this is the example that they tend to use. So this is an easy one to find. So once you have this file, I literally copied this as my fruits Mask RCNN. I'm going to work with the fruits dataset, and I edited my fruits RCNN file. So what changes did I make? So if I added a few other libraries. We'll go through that later on. But if you look at the meat of it, the code, it starts off by starting off with a class for your dataset. Here it's called Kangaroo dataset. So I was being very creative there. I just called it fruits dataset, and within that class you have multiple methods, multiple functions. Here it's about loading a dataset, right? So the next step is about loading a dataset, and as you're loading the dataset, you're adding a class. And here they had only one class for Kangaroo, and for us it's a multi-class. So I added the 3 classes with numbers 1, 2, and 3. Assigning them to apple, banana, and orange. If you have more classes, now you know what to do, right? So this, I hope you can use this file as a template for your own purposes. And then it defines like what my image directory is, annotations directory is, and you'll see that both are almost identical. Both these files are almost identical. Here they say, up to image 150, it's for training, and if not, it's for testing, right? So I just did 250 because I have a few more images. So that's pretty much it. Not many changes over there. Now, part of that is also extract boxes, because you're reading the labels. So extract boxes is, of course, loading the mask, and extract boxes is there. Apparently, I kind of moved things around. So here I have extract boxes first. And so let's go ahead and look at that first. Extract boxes. And again, they are using part of XML library, you have etree, and then you're actually getting we'll look at the XML file in a minute. But from the XML file, go ahead and get these xmin, ymin, ymax, xmax. That's exactly what I'm also doing right there. Xmin, ymin, xmax, ymax. And I changed this slightly, again, based on how I'm reading my masks and all that. In fact, it's a good time to go ahead and what annotations am I in? I'm in the fruits one, so that's okay. Let's go ahead and look at the annotations. First of all, let's look at image number 007, right? So we have banana, orange, and apple there. So we should have in our XML file 007, if I can open that right there. So let me open this in Notepad++. So 007 XML right here. So you can see this is how the format for the XML. And what do they have? So here you have a class orange at the bounding box right here. This is my xmin, ymin, xmax, ymax. You see how it says bounding box right there. So we are going through, let me minimize this one so we can look at this. Okay, so from our XML file, look at objects, find all objects, which is that one, right? And the next object is banana, and the next object is something else. So how many objects did you find? And that's what the XML file actually contains as part of the annotations. And within an object, go ahead and look for the name, find the name. In this case, the name is orange. In the next case, the name would be banana. Once you find the name, go ahead and find the bounding box xmin, ymin, which is this one. Yeah. So bounding box right there. BND box. Within BND box, go ahead and look at xmin, ymin, xmax, ymax. That tells you exactly where the bounding box is. If your data is not like in the form of a bounding box, but then different clicks, then you'll have the coordinates show up right here, which we'll see in the next tutorial. Although we'll be using JSON file format in the next tutorial, but the process would be pretty similar. Okay, that's it. So we are getting the bounding boxes, and then how do we load the mask right there? So loading the mask, let me minimize this. Again, I'm just following exactly what they have done right there. So here they're adding class names right here, and I'm also adding class names right here. So if it's one right there, I mean, if the bounding box is, if the name of that box equals to apple, then go ahead and assign a label of apple to that. And so we have 3 different labels, and that's what we're adding right here. And yeah, so everything else is just a copy from the kangaroo training right here. Yeah. So once that is defined, then we are going down and we need to define a config file. A config file has all the information about the configuration for the MRCNN. You can define a whole bunch of stuff as part of config file. Here it's defining the GPU count in case you're using multi-GPU, like what's the GPU count and number of classes that you have. Number of classes equals to 2. They defined this as 2. And if you have only kangaroo, the classes are 2, kangaroo and the background. So it's your number of objects plus the background. And they define steps per epoch. And what did I do right here for my config file right there? I named it fruits _ configuration, and number of classes equal to 1 plus 3, background plus 3 fruits that we have. Yeah, and steps per epoch, I just left it to 100. Okay, so that is the bulk of it. And once you have the data ready, the configuration ready, then it's just a matter of saying, okay, what is the path to store your logs, and giving your model, or in this case, we are doing a transfer learning. We are usually not starting from scratch. We do transfer learning, meaning you already have Cocoa weights. So that is something that you need to download. I showed that in my last video. I have done that anytime I have a model. I have a where is it? The weights directory and Mask RCNN cocoa.h5. So go ahead and download that. I'll leave the link to that down here as part of the description. And then once you have that, let's minimize this. We load those weights first. Yeah. So first, let's define our model as Mask RCNN. We are in the training mode, and our directory for saving the weights is logs, and then load the weights and load the Cocoa weights that I just showed you. And once you have the cocoa weights, go ahead and start the training. Training on what? On your training set and test set, and you can define your learning rate, you can define your number of epochs, and so on. That's it. Once you have the training, then it's a matter of prediction. And also for prediction, you need to define the configuration. So you can use the same configuration pretty much. Again, I'm not reinventing a lot of stuff. I'm just copying whatever you find under the Kangaroo dataset. So I opened the Kangaroo training. If you open Kangaroo prediction, you will see pretty much the same structure right there. You start with your prediction configuration, and then once you have the prediction, you load the weights because we already trained them. And once you load the weights, it's a matter of inference. Okay, that's a quick run through of what's going to happen, and I am going to share this file. I'm not going to share Kangaroo training. I don't own that, but of course you can download it from any, I mean, you have probably already downloaded that anyhow. So let us close everything that's irrelevant and now focus on running this code. So these are all the libraries that we need, and bulk of them are coming from MRCNN that we installed in our previous video, and NumPy, of course, and XML because our labels are XML. If we are going to use JSON, then you have to import JSON to load your JSON annotations. Okay, so that part is done, and the next step is let's go ahead, and we already discussed what this class does, so let's go ahead and run this class part all the way up to down here, and then comes the actual execution part. So now let's go ahead and define our dataset directory. I just showed you that I have a directory called rename to numbers. That's my dataset directory. So let's run that. And let's instantiate this training set. My training set is fruits dataset, and again fruits dataset right there. Yeah, so that is my where are we? Let's get back. Yeah, that's my training. Let's run that line, and now let's training set dot load dataset. And where is our dataset coming from? It's from coming from right here. So basically that object is going to look at our dataset directory, and of course what does it expect in our dataset directory? It expects to see images and annotations, and it just follows this loading the dataset path. I hope you know that. Okay, so let us come down to that step. Let's go ahead and load the dataset, and here I added a print statement so I can see exactly what's going on. So loading the dataset. Now let's go ahead and prepare it, and let's go ahead and print it. What's going on? What is in my dataset? So I have 249 training images, and the remaining are testing images. And let me switch to plot so we can do some plotting. Let's do pretty much the same with our test set, right? So for our test set, everything is the same except eStrain equals to false. So let's do the same steps right there, and go ahead and prepare, and go ahead, and there you go. So 51 out of 300 images are assigned for testing. Now let's display a few random images and corresponding annotations, just to make sure that again, this is a sanity check I try to do all the time before I start training the model. So first thing first, let's go ahead and import random, so we can go ahead and load some random images, and just load a random image right there, training set. So my image ID, I'm calling it number. I just imported random. Let's generate a random number between 0 to how many ever images we have, and my image ID is whatever that number is, and let's go ahead and assign an image to that specific ID. And let's also do exactly the same with our mask and class IDs, yeah, because when you do train set dot load mask is part of our class, as you know. It's going to load that corresponding mask for that specific image. And we also have bounding box as extract bounding boxes as part of our class up there, I think, right? So extract load mask image inference extract boxes right there. Extract boxes. Okay, so we are going to do and display instances, and display instances is a cool thing that is part of your MRCNN visualize right there. Okay, so by the way, we used extract bounding boxes. That is also part of MRCNN utilities. Sorry that I said it was part of our class. Part of our class was extract boxes. We'll use that later on. Okay, so coming back down, so we are going to extract the bounding boxes and then display the instances. So let's go ahead and display the instances for this specific random image. That is cool. So the bounding box, and it says orange. I know you can't see it, but it says orange up there. I'm happy. And let's do this for a few images. Let me run this a couple of times just to make sure. That is also orange. That is a banana. It writes text banana in white, so we cannot see it against this background. But the bounding boxes, it's actually doing a good job in terms of detecting the bounding or drawing the bounding boxes. So yeah, it's tough to see, but there are apples behind the scenes, behind those boxes. So banana, banana, I'm happy. I think we have proven that our images and masks are being loaded the right way. Okay, now let's define the configuration. So fruits config, I already talked about this. When you do that, we can actually print the config so you can see all the other defaults that are part of configuration file. So this is what I defined, but if you just go to fruits config and config.display, you can see pretty much a whole bunch of stuff that is part of your config file. If you want, you can define those. If you don't like ResNet 101 to be the backbone, you want something else, define that as part of config right here, right? So that holds true for a whole bunch of other settings that we are not even defining right here. We are just defining the name, the number of classes that we have, and steps per epoch. That's it. Okay, now we are getting there, almost ready to train. So let's go ahead and import the OS so we can define the absolute path for the root directory, so it can store its log files in the root directory, and also the weights as it's training. So there you go, and default log directories is the one that we just defined right here, root directory. Now so in my case, they were being saved at a different location, and I took a note in terms of how to investigate, go ahead and investigate why this is happening. But after checking this, it's actually working fine. So let me delete my personal notes right there. And now let's go ahead and start defining the model. So we again went through this line by line a few minutes ago. So let's go ahead and run this. And now you instantiated this model. You defined the model as a Mask RCNN model, but now we need to populate that with weights from pre-trained model. And for that, I'm going to use Mask RCNN Cocoa weights. They are in the HDF5 format. So let's go ahead and load that. So now my model is ready with pre-trained weights. In fact, I can go ahead and start doing my inference if the objects are one of the original objects that are part of the Cocoa dataset. Obviously, I don't know if these are, but we need to do our additional training. That's how we do it right here. Model.train, go ahead and train it. And let me start. I mean, I've trained it for 20 epochs. Mask RCNN is very slow. So I trained it for 20 epochs and saved the model, but I just want to show you that, okay, this is actually running. By the way, I'm in the same environment that we created in our last tutorial, the same Mask RCNN environment. So yeah, everything is working fine. It started my epoch 1 out of 20. And let me kill it so we can proceed with the inference part. So for the inference part, again, I want to display these rectangles on the image. So from matplotlib.patches, I'm importing the rectangle method. So that's that. And the configuration, again, exactly the same as the configuration before. I'm defining it again in case you want to copy this part of the code and put it in a different file just for inference. But right there, nothing different. And now I'm creating the prediction configuration right there. So I'm calling the prediction configuration. So this is the object for that. So go ahead and do it. And now my model is Mask RCNN, just like we did the last time. So we need to load the model. We need to load the weights. So I'm loading the model and I'll load the weights once the model is defined right there. So now I'm loading my Mask RCNN fruits 20. So if I go back here under logs, I have Mask RCNN fruits config 0020. This is the file that got, in fact, it saves the model after every epoch. I deleted the first 19, just saved the 20th one. So that's what I loaded. And let's go ahead and test it on a few random images. So first of all, let's load scikit image so we can open our images. Now we are inferring this. Now we are predicting on our own images. So I did a quick search for fruit bowl. And this is the image that I got when I did the search. You can see the link right there. So this is the image. I just saved the image, and let's go ahead and infer on that image. So my fruits image is the fruit bowl that I just downloaded from my Google search. And let's do model.detect. Typically it's model.predict. If you're used to Keras, model.detect. Let's run that line, and now I should have my detected. If I go to Variable Explorer, you should see my detected is a dictionary. If I open that, what does the output look like from model.detect? It has the class IDs. It's showing me multiple class IDs because I have multiple objects, right? If I go back here, I have, I don't know, at least definitely more than 10. It's telling me it's 16 right there. So all the class IDs for each object it detected, and then the masks and ROIs, like for each of these 16 objects, it has the bounding box ROIs. That's why you have the 4 coordinates right there. And then the score, like what's the accuracy, like 98%, 96%. So if you want, you can display this on the screen. So all the information is right here. Now we just need to take our original image and overlay the masks or ROIs on top of it. Okay, so how do we do that? It's just a plotting right now. And I defined the class names, so I can add the class names to the plotting right here. So let's go ahead and run this, and we should see the response right there. So apple, 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 banana, banana. You can see the label right there. Maybe you can put it at the bottom corner if you want. Apple right here for this one. So it is doing an amazing job, as you can see. So this is how you go from training to prediction using a data set that's available on Kaggle or somewhere else. In the next video, let's go ahead and do pretty much the same exercise, except start with your own images, do your own annotations, download the annotations, and go ahead and get started with the training and prediction part. So I hope I'll see you guys in the next video. Until then, please do not forget to hit the subscribe button. Thank you.